All right, inverse trig functions. So the first part of this is going to be very, very familiar. They just define it in a more explicit way than what you have seen in the past. So we have seen trigonometric functions and inverses of trig functions. So we're accustomed to sine and arc sine. You will have seen it like on your calculator. It looks like this, right? It's what happens when you're calculating the angle measure. But arc sine is the inverse of sine. Now, if you were talking strictly across the entire domain of sine from negative infinity to positive infinity, arc sine is not an actual function, because if you were to flip that, you would see it wouldn't pass the vertical line test, right? But if you limit it to a certain, like to one period where it doesn't repeat, or even on like sine, you only can do half a period, then that is a function. And so that's what they have done here. They have taken these and they have given you the limitations. So we have y equals arc sine is a function of x, if and only if sine of y equals x. So these are inverses of each other. That's all that's saying. We have the domain and we have the range. So that means that we have this from positive pi over 2 to negative pi over 2 limitation. Why is that? Because if I were to do the entire unit circle, the arc sine would not be a function because it crosses more than once, okay? Because it's a cycle, right? And so think about your sine graph. If you were to turn that sideways, it doesn't pass the vertical line test. But it would if you only did half of the cycle, which really covers all of your positives and negatives. That's how we did that when we did arc sines. Remember, when we did an arc sine, we said, okay, I'm only going to consider from positive pi over 2 to negative pi over 2, because that takes care of all my positive and negatives y's anyway. Okay, and so that's what they're doing here. They're just limiting it so that it is a technical function. But these are the inverse functions, just like you're used to. You can think of it as sine to the negative 1, cosine to the negative 1. It will be written both ways, but that's what arc sine means. So let's look at these. You should be able to evaluate these without a calculator for the most part, other than maybe this little guy right here. These are on the unit circle, okay? And so when it says arc sine of negative 1/2, it is saying what angle gives you a sine of negative 1/2, and we are only talking from pi over 2 to negative pi over 2. Well, if it is a negative 1/2, it has to be down here because that's where my negative y is, okay? And remember, a sine of 1/2 is a 30-degree angle, or pi over 6. So if they do it this way, from 0 to pi over 2 that way, and from 0 to negative pi over 2, what's nice about it is you don't have to remember the unit circle all the way around. You just have to do the negation of it. So if pi over 6 gives you 1/2, then negative pi over 6 is going to give you negative 1/2. Now that's not true with cosine, because cosine takes the first and second quadrant, so you do have to remember all the way across to pi. But for sine, you're like, okay, a pi over 6 gives me 1/2, negative pi over 6 will give me negative 1/2. So that is the angle that will give me a sine of negative 1/2. We're just figuring out the angle. We're working back to the angle. Look at cosine. All right, now cosine, in order to get all your positives and negatives for cosine, you have to go from 0 to pi, right? So that gives me all the positive and negatives of cosine, because that's my x value. So what cosine gives me a 0, this is only has a 1 answer here. So which value gives me a 0 for cosine? Well, that's right here. That gives me a 0 for cosine. So I only have one option here. It is pi over 2. A 90-degree angle has a cosine of 0. Tangent. Tangent is actually going to follow the same logic as your sine, okay? So we would just do the first or the fourth quadrant. Why? Because this is going to have a positive tangent. This is going to have a negative tangent. It will cover all my tangent possibilities. Square root of 3. This is going to be my numerator. Square root of 3 over 2 over 1/2. All right. So what gives me a square root of 3 tangent is pi over 3. And because it is positive, I'm going to say positive pi over 3. What angle gives me a tangent of square root of 3? That is pi over 3. Remember, tangent is sine over cosine. The sine of pi over 3 is square root of 3 over 2. The cosine is 1/2. That reduces to square root of 3. right? This last one is not on my unit circle. Not on my unit circle, so I'm going to have to use a calculator for that. So in your calculator, you're going to use the shift sign. It's going to open a parentheses. You put your 0.3 close parentheses. The key itself is the sign -1. So go ahead and put that in and make sure that you get approximately 0.3047. Properties of inverse trig functions. This is basically just telling us that if you are in the -1 to +1 and your y is from -2 to -pi/2 to +pi/2, then you can go from the sign of the arc sine or the arc sine of the sine and get what's inside. So what they're basically telling you here is that inverse functions cancel each other out as long as you're within the domain and range that you're supposed to be in. So, for example, they have right here, think of it as like natural log and e, how they cancel each other out and you get what's inside. If I take the sine of the arc sine of x, I'm just going to get x because these two guys cancel each other out, okay? Because if x were, let's say x was pi/2, or 1. The arc sine of 1 is pi/2, and then the sine of pi/2 is 1. So I'm just going to, they just cancel each other out just like natural log and e cancel each other out. As long as you're within the domain and range that you're supposed to be in. If you're not within the domain and range, you actually have to work it out to make sure that you fall within the domain and range. They give some examples here. Example 2. So for this one, arctangent of 2x minus 3. I can just take the tangent of both sides, just like I would do with a natural log. I can say, okay, tangent of this side, tangent of this side. On this left-hand side, those two cancel and I get 2x minus 3. On this side, I have the tangent of pi/4, which is something I actually should know from the unit circle. The tangent of pi/4 is just 1. And now I'm solving a like algebra 1 size equation. Add 3, divide by 2, x equals 2. And you can always plug it back in and check. But if you plug that in, you get 2 times 2, 4, minus 3 is 1. The arctangent of 1 is pi/4. That's true. Using right triangles. Given that y equals arc sine of x, where y is between 0 and pi/2, find the cosine of y. That's the first one. So basically what they did here is they drew a right triangle. If y is the arc sine of x, then y is the angle, right? Because arc sine finds the angle. So y is the angle here because it says y equals the arc sine of x, okay? So y must be the angle if y equals the arc sine. Anytime you're using arc sine or sine to the -1, you're finding the angle. So y is the angle. X then is the sine of y, all right? Well, sine is opposite over hypotenuse. X over 1 would be opposite over hypotenuse, right? So then how did they get this side over here? Pythagorean theorem, yes? So if we know that the sine is x, which is x over 1, then how do I get this third side of my right triangle? Well, I'm going to say a squared plus b squared equals c squared. If I know the c and the b, I'm just going to subtract 1 squared minus x squared and take the square root. That would give me this leftover side of a right triangle. So then if they want me to find the cosine, which is what they've asked for, well, then the cosine of y is just going to be adjacent over hypotenuse. In this case, square root of 1 minus x squared. All they did was use a right triangle. A squared plus b squared equals c squared. Look at the next one. The next one says that given y is the arcsecant, again, y must be the angle because I'm using arc, okay? So that means the secant then of y should equal the square root of 5 over 2. What is the secant? That's the reciprocal of the cosine, right? So I can assume then that the cosine of y is 2 over the square root of 5, which means my adjacent side is 2. My hypotenuse is square root of 5. They want me to find tangent. Well, tangent is opposite over adjacent. So once again, I have to use my Pythagorean theorem to solve it, right? Make sense? So that's 4 plus x squared equals 5. Subtract x squared equals 1, so x equals 1 right here, which means if I want to find the tangent, which is what they ask for, it is going to be opposite 1 over adjacent 2. My tangent is 1/2. So like most of your trig functions, we could go through the process of finding these, but you really need to memorize them. There is a pattern, so always look for a pattern. The sine and cosine go together. So we're no longer talking about the derivative of sine. We know the derivative of sine, it's cosine, right? We're talking about the derivative of the arc sine. Okay, the arc sine. This is a function. U is some function, x squared, 3x squared, whatever. This is a function. So the numerator is going to be the derivative of that function. The denominator is going to be the square root of 1 minus the square of that function. You'll notice that cosine is very, very similar. The only difference is that cosine yields a negative, which is true of derivatives of sine and cosine. Okay? So we have the derivative of the function over the square root of 1 minus the function squared, the negative derivative of the function over 1 minus the function squared, square root. So those are your sines and cosines, arc cosines. Then we go to tangent and cotangent. Again, they look identical, right? Arctangent is the derivative of the function, then 1 plus the function squared. Arccotangent is the negative derivative of the function, 1 plus the function squared. And then secant and cosecant go together. Derivative, absolute value of the function, square root of the function squared minus 1. These you will have a tendency to confuse, by the way. The sine and the secant, you can see how this is 1 minus the function squared and this is the function squared minus 1. But these two go together. This is just the negative of that guy. All right? So we're going to do just a little bit of plugging in so you can see what they look like. They want us to take the derivative of the arc sine. So we're going to go to our derivative of our arc sine. That tells me to take the derivative of what's inside. What's the derivative of 2x? 2. And we're going to put that over the square root of 1 minus this function, 2x squared, right? So if I simplify that, that's 2 over the square root of 1 minus 4x squared. That is my derivative. Okay, so we're just plugging them in. That's why you need to memorize them, right? Look at the next one, arctangent. Arctangent is the derivative of the inside, which is just 3 over, this is 1 plus that function squared. So it's going to look like this. All right. You need to learn this because we are going to be taking antiderivatives of these, right? Arc sine, once again, okay, so this one's a little bit more complicated because the derivative of this is a little more complicated. The derivative of this is 1/2 x to the negative 1/2, right? Over the square root of 1 minus x squared of x squared. So we can definitely simplify this guy, right? The 1 stays on top, right? But that 2 can go to the bottom, right? Something else can actually go to the bottom. The x to the 1/2, I would write it like that, right? And then we also have times 1 minus, and if I square a square root, it looks like that, all right? When I multiply radicals, what can I do with them? Like if I had square root of 2 times square root of 3, what would you tell me that is? Yeah. So this is the square root of this guy times the square root of that guy. I can actually distribute him through on the inside. So that's going to be 1 over 2 square root of x minus x squared. Okay. You need to see that process because there are going to be times when you're taking the antiderivative and you need to recognize that you could actually pull something out of it and it would be an antiderivative, right? Let's look at this, arcsecant, all right, arcsecant. Arcsecant is the derivative of the inside. What's the derivative of e to the 2x? Well, that's going to be e to the 2x times the derivative of the 2x, which is 2. So that's my derivative there. And then arcsecant is the absolute value of each of that function, but e to the 2x is never going to be negative, right? Because e is 2.17, it's never going to be negative. You can't raise it to any power. So this you don't have to put the absolute value here. You can just do this guy. All right? And then we have the square root of e to the 2x squared minus 1.
Would you take off if we put it in the absolute value?
No, I mean, you can put it in there, but it's unnecessary. Yeah. You can put it there if you want to, but it's not necessary. So then we have in my numerator 2e to the 2x. Before we do that, let's simplify this a little bit. Let's simplify the outside first, then we'll simplify the inside. If I have this here and this here, I should be able to do that. Yes? Okay. So on top, I just have that 2. And then in here, if I have a power to a power, what do I do with those? Multiply them. Power to a power is multiply. So that's 4x minus 1. And we're done with that one. Remember, if you're taking a derivative of two things added together, you can just take the derivative of them individually. And so that's what I would do here. I would actually take the derivative of my arc sine first. If I'm trying to find the derivative of y, I would do the derivative of arc sine. Well, the derivative of x is just 1 over the square root of 1 minus the square of this guy, which is x squared, plus, that's going to require product rule. Or you could, I mean, it's a couple ways you could do this, but we're going to use the product rule here, right? Because we have 1 minus x squared to the 1/2. So we're going to use product rule. The derivative of the first is just 1. So derivative of x is just 1 times the second, 1 minus x squared. And then to that, we are going to add the first, which is just x, times the derivative of the second. Well, the derivative of this guy is going to be 1/2, 1 minus x squared to the negative 1/2, times the inside derivative, negative 2x. All right? So I just did product rule there. And now I'm going to do some simplifying. Okay, if I simplify this guy, here's what I'm going to do. I'm actually going to put these beside each other so you can see that they will combine, okay? So I have 1 over the square root of 1 minus x squared. Over here, let's see what simplifies. Well, my 1/2 and 2 will cancel out, right? Everybody see that? And then my x and negative x will be a minus x squared in the numerator, right? And then because this is a negative exponent, that's going to go to the denominator. All right? So far, so good. And then I have this random guy out here, plus my square root of 1 minus x squared. All right, so let's look at this little guy here. I have common denominators, don't I? So I can combine these numerators here. I have 1 minus x squared. And that is to the first power, yes? Over my denominator, which is 1 minus x squared to the 1/2 power. What do I do when I'm dividing like terms? What do I do with their exponents? I subtract their exponents, yes. So 1 minus 1/2 gives me just a 1/2, right? So I end up, what is 1 minus x squared to the 1/2? That's the square root of 1 minus x squared. That's how that simplifies, right? Because I'm just subtracting these guys. Plus the square root of 1 minus x squared, those are like terms. So 1 and 1 give me 2 square root of 1 minus x squared. Photographer's taking a picture of a 4-foot painting hung in the art gallery. Camera lens is 1 foot below the lower edge of the painting, as shown below. How far should the lens camera be from the painting to maximize the angle subtended by the camera lens? All right. So they want to know what angle beta is. Beta. That looks like a little b. So beta is going to be angle alpha, which is all the way from the base up to the top of the painting. Minus theta, minus alpha, which is that little angle that's created from where it's at to the bottom of the painting. So if I want to find this, x is what I don't know. This guy right here all the way down is 5, right? 1 and 4.
I didn't know we'd be writing and ranking like this.
So if I were to do what is theta, well, I would say, well, it is going to be, we're using cotangent because we don't want x in our denominator. It's going to be adjacent over opposite. Cotangent of the adjacent x over the opposite 5. That's going to give me theta. Minus alpha. Well, alpha is going to give me the cotangent of adjacent x over its opposite, which is 1. So that should give me this little angle right here. If I subtract those two, the full angle minus the little tiny angle, that should give me that one. So now I'm just going to do, it says maximize. How do I maximize? I take the antiderivative and set it equal to 0. Yes, that's my critical number. So antiderivative of cotangent, well, that's going to be the derivative of this guy. That's 1/5 over 1 plus my function squared, x plus 5 squared. That's cotangent, right? And technically this is a negative, all right? And then cotangent over here, that's going to be the derivative of that guy over 1 plus that guy squared. That's what happens here, okay? And so, honestly, this is just becomes, let's do the math really quickly so that we can get this done. X squared over 25. To get rid of my denominators, remember I multiply everything by my common denominator. Yeah, everybody know that? Okay. And so on the top here, 25 times negative 1/5 is negative 5. On the bottom, I get 25 plus x squared minus a negative, so plus 1 over x squared. My common denominator here is these multiplied together. So I end up with negative 5 times that guy plus 1 times this guy all over my common denominator. The reason I'm not multiplying that out is because it doesn't help me, okay? When you simplify this, distribute and add like terms. That's all you do. You end up with 20 minus 4x squared. If I simplify this, 20 minus 4x squared over that denominator. Where is this 0? Well, that's where my numerator is 0, right? There's only, is positive or negative square root of 5? We're talking about dimensions here, so we wouldn't use negative, right? So if I set this guy equal to 0, subtract 20, divide by 4, you get 5. X squared equals 5, so x equals the square root of 5. That is going to be my distance, okay? That's going to be my x. That's what I just solved for, is x. If they want to know the angle, I just plug it in. Plug in square root of 5 here, plug in square root of 5 here, and use my calculator to get the angle. And then you'll get the angle measure. So you're just basically using right angle trigonometry throughout this whole process.